using our other property now to get these other two. So first one, queued S, we are using on this one the fact that we have a diameter so we have a diameter, and we are told that that diameter is perpendicular. How do we know it's perpendicular? Because it's making a right angle. So perpendicular, that's the symbol for perpendicular. And that information tells us that the chord is getting bisected. So in other words, that the diameter is acting as a bisector. So because we know that the diameter is perpendicular, then it bisects this chord. What does bisect mean? Bisect means it splits it in half. Splits it into two equal pieces. So here are my pieces. This one's 11, so this one is also 11. So when you see that diameter coming down on the segment, that means the pieces are the same. So if you know one of the pieces, then that tells you what the other piece is. So because these are each 11, Q to S the entire way across the segment, it's going to be 11 and 11, which is 22. Now, I want to go back and show you the theorem again because once again, we have a diameter. Once again, we have it perpendicular. So once again, that means that we are bisecting. But I want to remind you that the theorem, the idea said that we are bisecting the chord and its arc. So that means not only does the segment get split in half, if I have the arc in front of me, it's also split in half, split into two equal pieces. So this arc right here, since this piece was 40, so is this one. And so the entire arc from P through Q out to R, 40 here, and the other piece was 40, for a total of 80. And it asks you to provide justification, so I'll show you that as well, so that you can write that down, and maybe also seeing it visually will help these ideas also click into place for you. So here is how we would write the explanations for each of these three problems. The first one is saying because the chords are the same, then the arcs are the same. These ones are talking about the diameter being perpendicular will mean that we have a bisector. So those are my explanations written out. So again, diameter being perpendicular means that it's going to bisect. Here's the other way those types of problems are going to look while you're writing this down. Because these are using perpendicular in the same way that the first set of problems did, that's going to bring Pythagorean theorem back. Let me show you how. So you might see a problem like this, where you've got the diameter, you've got the perpendicular here, and then the other thing you might have drawn is that because we have this diameter here, you might see a radius drawn out like this, and now we have a right triangle. And in that case, you'll have to use c squared equals a squared plus b squared. On the homework tonight, every problem involves Pythagorean theorem in some way. Some of them you'll have to find the right triangle. Some of them, it just is going to depend on the problem. So again, all these homework problems are going to involve using Pythagorean theorem in some way to solve. Some of them you'll have to draw the triangle yourself when you are setting those up. All right. Next. This is back on the front page. There was one more that we didn't write down. We're writing it down now. In the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the center. There's our if and only if again, which means that if we have if and only if, that means the statement can go both ways. So that means two chords are congruent means same distance from the center. And that can work the other way around too. Same distance from the center means the chords have to be the same. Now, how do we measure distance from the center? We measure distance from the center because that means that we're measuring the distance that the chord is from the center, which will be the distance between a segment and a point. So how do we measure a distance between an entire segment to a point? Our convention is to drop down a perpendicular from the point onto my segment. So take from the point and then dropping down a perpendicular. So that's why you'll see these perpendicular things coming out from the center. That is saying the distance from the center is the same. So if these distances away from the center are the same, the chords are the same. If the chords are the same, these distances from the center are the same. That's power of my if and only if statement. Is that it can go in both directions. So let's look at some examples that might use those. So I'll give you a minute to think on these next two. One of them uses the theorem I just showed you. Chords being the same distance from the center. One of them uses something else to set up the equation. So I'll let you look for a moment and decide which one is setting up which. So between 1 and 2, which one is showing two chords and their distances from the center? It's number 2. The two chords being the same distance from the center. That means the chords are the same. So we're going to set them equal to each other. I'll let you try and solve this equation before I show you the whole solving process. But we're setting them equal to each other because same distance from the center means the chords are congruent. Congruent is going to mean they measure the same. So we're setting them equal to each other. Get everything with x on the same side. Add, divide. We get 10. Now, the first one is using a slightly different idea. The first one says we have diameter, we have perpendicular. So since we have diameter and perpendicular, that's going to tell us bisect. So we are still setting these equal to each other, but it's for a different reason. Diameter is perpendicular to the chord, means the chord is bisected. Bisected means split into two equal pieces, so we can take the pieces, set them equal to each other, and we're going to solve. And we get 1 for x. If you want to check your answer, you can plug those in. For x at the end and make sure that those are the same. So like we said, x was 10 here. So that means these two should match. So on the left side, we have 10 plus 9 is 19. On the right side, we have 3 times 10 is 30 minus 11 is also 19. And there we have those two chords being the same. So we have a few different types of problems and diagrams that we're working with here. The main ones you're going to see on the homework is the ones at the top of the page where you have the radius and the tangent line being perpendicular to each other. And then this first one where you have the diameter being a perpendicular bisector to the chord. Those are the main ones you're going to see on the homework here. Questions? Ready? Okay. Last problems here. Determine whether P to R is the diameter of the circle. Well, the property that we have to get a diameter is if one chord is a perpendicular bisector to another chord. So if we have a perpendicular bisector, then we have a diameter. So that tells me that we need two things to happen. One, we need it to be perpendicular, and two, we need it to bisect. And we need to check them both. Both of them need to happen. So on this first one, give me a thumbs up or thumbs down. Are we told perpendicular? Yes, we are told perpendicular because we got a right angle sitting right here. So yes, we have perpendicular. And then question number 2, are we told bisector? I see some thumbs up. Remember, if we're told bisector, then there are a couple different ways to show that. But you need something that shows that these two pieces are exactly the same. It cannot just be, well, they look the same. It has to be, there's some tick marks here, or there's some measurements that are the same that I'm putting in front of you. Which in this case, there's nothing else marked in this diagram. So we are not told bisector. On the second one here, we need to be told perpendicular. We need to be told bisector. This time, we are told bisector. We are told that these are both 8. So these two pieces are the same. Are we told perpendicular? No, we are not. Right? Perpendicular would make a right angle. No right angle labeled. It's not just, oh, it looks perpendicular. It's got to be marked, and it is not. So over here, we have perpendicular but not bisector. And on this one, we have bisector but not perpendicular. So we cannot determine diameter because we don't have both perpendicular and bisector for either one. So those are kind of using the theorems and properties that we have on those.